Okay, so we want to do 52 out of 5.3, which says find the domain of y of x is 1 over 2 minus the square root of 7 minus e to the 2t.
What's that?
I would like that.
Okay, cool?
Yeah.
How do you find a domain?
X coordinates.
Anything, if you look for
All
problems,
real numbers.
Yeah.
Always.
No.
Always.
Okay, so you can start with the big R and then take off all the problems, right?
0.
So,
can't have negative.
what about 0? What can't be 0? This? Yeah, this can't be 0. It's a fraction with a 1 on the top. It's not 0.
You can't divide by 0, so the whole bottom thing can't be 0.
Thank you, good. You can't divide by 0, so we should set the bottom equal to 0 and find out where that's going to screw us up, right? So we should set 2 minus the square root of 7 minus e to the 2t equal to 0.
Honestly, I just simplified it to 7 minus e2t equals 4.
Okay, cool, yeah. So
Because 2 minus the square root of 4 is 0.
add this junk on the square root thing, right? Add the square root junk to the other side. So you got 2 is the square root of 7 minus e to the 2t. Square both sides. Yes? So you get 4 is 7 minus e to the 2t. Then what?
Then we subtract 7.
Subtract 7. So you got negative 3 is negative e to the 2t. Put the signs on both sides.
So wait, could you? I did something in chemistry where they just, or if it was like a step like that, they just added 7 to the other side. Is that the?
Added 7.
Or no, I don't think that would work because you have you're subtracting and then you're dividing by a negative.
Oh yeah, you could add this to the other side and then subtract 4.
Oh, okay, never mind. I'm thinking of something else.
Alright, so flip the signs. You got 3 is e to the 2t. Then what?
Then we natural log both sides.
Log both sides. Okay, so then you get natural log of 3 is 2 times t.
Then we divide by 2.
Then you multiply by a half, rather. So you get log of 3 over 2 is t. And what's that?
That
Where
is
is
the
this
thing that
zero?
you can't do.
Yeah, this is the thing you can't do. Is this the only thing you can't do?
I want to say
What about the negative?
because you can't have a negative in the radical. So
Yeah, good. I don't know how to square root negative numbers either, right? So this is causing...
So anything greater than 0.
Yeah, so hang on.
Except that.
So let me take that value, put it over here, and just like... Bad list, right? Natural log of 3 over 2. Like, that one's not cool. So then what else do I need? I need the thing under the radical to be...
Not equal to 7 or greater. Yeah.
let's see, yeah. So I need the thing under the radical, 7 minus e to the 2t to be... What?
less than 7.
Okay. Wait, what?
We're talking about the e.
I was thinking
Greater than
This whole thing, I need it to be
Greater than 0.
bigger than 0. So right now I'm operating
It
on...
can't be equal to.
Well, he's just doing.
But it can't be 2 minus 0.
That's what we just put. We just found how it's equal to
You guys see this? So I have a bad value over here, right? And now I'm looking at good values over here.
Yeah, so it has to be 0 times 2.
Cool?
zero. Why is everything under the radical? And not the whole thing.
There's other bad things.
So I'm worried about the whole bottom of the fraction being 0, right?
Yeah.
That's going to cause me to divide by 0, which I'm not allowed to do. I'm also worried about applying the square root function to things that aren't in its domain. Right? I don't know how to square root negative numbers. Right? So if this stuff in here is negative, that's also bad. These guys supplied bigger than 0, so I'm approaching that as these are things that are good, right? So how do I solve this thing?
the same way as a normal equation, right? Except for you have to flip the sign if you do a negative.
Yeah, so you have to be a little careful with these, right? So if you apply a decreasing function to both sides, you have to switch the order of this thing.
So subtract
Yeah,
You flip
so
this
I'm going to just put that over there, right? I'm going to add e to the 2t to both sides. So I got 7 is bigger than or equal to e to the 2t. And then what?
natural.
Log it. And then natural log is an increasing function, right?
Yeah.
So you don't have to flip the inequality. If you apply a function to this thing, you damn well better be worried about flipping that inequality. So you log both sides, you get log of 7 is bigger than or equal to 2t. Then you
Divide by 2.
multiply by a half, which is also an increasing function, right? So you get log of 7 over 2 is bigger than or equal to t.
That's bad.
And these are the good values.
Oh, there's, okay. Yeah.
You guys see that? So this thing has to be bigger than t. So what's my domain then? How about number line? Peg that thing on it. So someplace here is log of 7 over 2. You guys with me on this? And then which stuff is okay?
Anything greater than that?
Anything what than that?
Greater than or equal.
Less than or equal to.
Oh, yeah.
So if you're not sure,
Oh.
which you're probably not going to be,
T has to be less than.
solve
direction
this
of the
thing
dash.
as equality, peg that value, get a numerical approximation. So log of 7 over 2 is like 1, give or take. Yeah?
I know I'm doing something.
Where'd I get that from?
Well, 7 is close to 10.
Yeah, 7's close to 9 and e's close to 3. So this is basically e squared. So log of e squared would be 2. 2 over 2 is 1. That's pretty ballparky, so I'm going to stay away from that. So I'm going to go up here and pick a number, right, like 10. And then I'm going to put that in under the radical and check. So I got like 7 minus e to the 20th.
Oh.
E to the 20th is a huge ass number, right?
Yeah.
When you subtract that from 7, that's going to be negative. So this stuff is bad news bears, not allowed. And then you pick a value down here, like
Negative 10.
Yeah, that's like 485 million.
negative 100 million. I mean, it doesn't friggin' matter. Just pick something on that end, right? If you put a really big negative number in the power of an e, that's going to get really close to 0, right? 7 minus 0 is positive at least, right? When I square root that, I'm okay.
What happens when the under the radical stuff is equal to 2?
Yeah, so that's this guy, right? So I need to know where this thing is. So is log of 3 over 2 bigger, smaller, equal to log of 7 over 2?
Probably smaller.
Probably smaller. Definitely smaller, because this is going to be about 1, right? 1 over 2 is like a half. Okay, so that's going to be someplace in here, right? So I can't include log of 3 over 2. You guys cool with this? Okay, this one was an okay value, right? Because that'll give me 0 under the radical, and I know how to square root 0. So what's my ultimate answer for this thing? I need like some kind of frickin' interval or something.
Domain.
Couldn't you just
less
follow
than
the
or
sign
equal to
since the arrow was going that way? You just it's a closed dot to the right.
Okay, so I think my domain, right? Where does it start on the left-hand end?
Negative.
Yeah, negative infinity, right? There really is no left-hand end, and we're okay all the way down. and we go up to
Oh yeah, 3/2.
natural log of 3 over 2,
Uh,
and that's not included, right?
No.
And then where's the next piece start?
oh,
Isn't
okay.
it, or what's it
Natural
called?
log of
Mu?
seven.
Or
Natural log of 3 over.
Yeah, the next piece starts right after natural log of 3 over 2, right?
yeah.
Okay, so it's not included.
So it starts at natural log of 3 over 2, but that end's not included. And then where does it go up to?
Natural log of 7 over
Natural log of 7 over 2.
2. Square bracket.
And that one gets a square bracket, and how do you stick intervals together?
That's what I was
You.
wondering. Mu.
Aha.
Yeah, one of these guys.
Or union.
You guys cool with this?
Yeah.
You want another way to write this?
No, I'm good.
That's good. I like that better.
Okay, so if you don't want another way to write this, shut your brain off for a second. So another way to write would be to go from minus infinity up to log of 7 over 2, included, right?
Except.
And then I need to take away the one value that doesn't work out, which is log of 3 over 2. You guys remember these funny brackets are a list, right? This is a list that has just one thing in it. If I had multiple holes that I had to punch, I'd just put them all in this list.
Just be comma, 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 and then end bracket, right?
Yep, exactly. So if I was going to make a longer list, yeah, it'd be A, comma, B, comma, C, comma, D, comma, whatever. And if they have some kind of nice pattern, you can also do this. You do A, comma, B, comma, dot, 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 comma, E.
Yeah.
Right, if you want to end it, and if you don't want to end it, you can just slash E.
And wouldn't you need to create a list like that? You need at least 3 points, 2 in the beginning and 1 at the end to show it's a pattern.
Yeah, you need to show enough of it to demonstrate the pattern, right? So if that's 2, 4, then I'm kind of left wondering whether the next one's a 6 or an 8, right?
Yeah.
So, yeah, give me enough to make sure that the pattern's clear. Cool.
So can we just not go into complex because we're not there yet in this class? Because I feel like when we have negatives, we can do things to it. We learned it now, number 2.
Totally fair. So the reason we're not doing complex numbers here is that this is a preparation for calculus, right?
Yeah.
Calculus doesn't do complex numbers because calculus and the complex numbers is a little bit different. It's got a couple of twists to it that are awesome, but are different.
Okay.
And so we want you to do real calculus first, and then we'll add the twists, and everything will get really goddamn confusing.
Cool. Can you
When's that
please-
come in? Is that calculated?
So complex calculus is like 4th year undergrad.
Oh, okay. Sweet.
So if you're not going into math, you may well never see it.
I will.
It is super, super cool stuff. There's a lot of tools there that don't exist elsewhere because you're doing calculus on a 2-dimensional space.
I can
So
only
that's,
imagine.
that's a lot
So-
of like electrical engineering stuff, isn't it?
Electrical engineering doesn't need it.
No?
They don't need to run calculus there. They need to understand the complex numbers, and they need to use them, but they don't need to run calculus on complex valued functions.
So then how come a veterinarian needs calculus? That was supposed to be in calculus 1.
That's just, it's simple.
Yeah,
calc
because
for
you need
chem.
to understand rates of change. And that's why we don't put the complex analysis stuff in there. I'm shutting this off.